Hello, everybody, and welcome to our little workshop. This time with Manu and Andy. Hello.
Hi.
Hey.
So, I hope everyone is feeling good. Everyone is here. Okay. Yeah. Annie, Andrea, Hendrik. Yeah, cool. Fine. Super. Okay, let's start. Manu, it's your turn.
Okay.
All right.
Yeah. Hey, my name is Manu. You've been at our shop, obviously, and I'm the one who ships all the stuff and who writes all the emails. So hello. Andy is new in the team.
Hello. I'm the new member of
yeah.
Exploding Chat.
He's an electrical engineer. Sorry, it's a bit disturbing. We have this echo thing going on. He's an electrical engineer, and yeah, so it's perfect for us. We can do much more work now. For the future, I have to take this off. It's crazy. The delay is crazy. For the future, we want to do, or let me say it differently. I was doing workshops as Leaf Audio for 10 years, and we did over 100 workshops. Meanwhile, we have Exploding Chat, the company, and we have families and everything, so we can't travel so much anymore. So our idea is for the future to make more workshops inside of the shop.
So do the workshops online then. And this is the second one now. We did the first one for Super Booth, and now we do the second one for SOUNDMIT. And meanwhile, hopefully, our camera technique has improved a little bit. The last time we had some problems with sharpness of the image, and so it was a bit difficult to see. But now it should be better. Yeah. If you have questions, don't hesitate to write comments in YouTube. We will see it. Everything is a bit delayed, so we have to deal with this delay. I wrote this by email too, but it works. And yeah, if we don't see the comments because we're working here, I'm sure Ronnie can help us out there and make us aware of it. Okay, we built the Befaco Stereomix, and about the technical details and function and so on, maybe Andreas can explain a little bit after the actual soldering, if we have some time left. I don't think the workshop will take too long because the module is quite simple, carefully chosen. And yeah, good. I would say let's start with a little bit of a soldering introduction. I will take this away. So I wrote this email about recommendations. Some really good things are this thing, of course, because you can clean your iron. Oops, now you can see it properly. You can clean your iron in a very easy way. This is super handy. Then you definitely need this kind of wire cutter to cut off the legs of the resistors and all the other parts. This kind of desoldering pump is also very interesting because you can heat up the contact and then remove the solder when you have done some mistakes. It's quite good. Yeah, then we have this kind of tape. We come to this later, which is kind of handy in a couple of, in einigen Fällen, würden wir in Deutschland sagen. Then you need a very good solder. Alles ist spiegelverkehrt. In former times, it was okay to use leaded solder, which was very easy to use. And then came the transition to lead-free solder, which was kind of a pain. But meanwhile, these things have improved, and this Kristall 611 is the best lead-free solder we could find. We did a lot of research, we tested tons of solder, and you should have one of these in your package included, I think, so you can try it out. Yeah, this is the module. It's not too much parts. So, and generally, I don't know what kind of iron do you have, but you should have one, as written in the PDF, with a sharp tip, pencil-like. There are also these screwdriver type irons. It's not so good in many cases, especially when you have to deal with these with the smaller resistors like Befaco use. Yeah, that's this. We don't have too many different parts actually. Generally, you always start with the most flat components, which is, you can see it from the side, in this case obviously the resistors, and then these ferrite thingies here. You have these diodes here. So, and then normally you build your way up, oops, in this dimension. The reason is very simple. If you start with these, with the high components, like this one here, for example, or the IC sockets, or these kind of resistors, capacitors, and you put it onto the other side for soldering, then it's not lying very good. So it's very hard to solder then. That's the reason why you start with the most flat components. And I would say, let's start. And we should start with bag A, with all the flat components. And then we take the resistors and put all the other stuff to the side for the moment. And then let me check the manual. We have 16 of 10K resistors. It must be this. And then you have these numbers. If you see the PDF, the manual, R3, R4, R5, and so on, and you find these on the silk screen print somewhere here. For example, R16, R18, and so on. So you have to look in the manual about the value, and then find the position, and then you can put all these resistors of that type in place. I like to use these small thingies like this for the garbage.
Okay, short.
Yeah.
Is everybody ready so far? Can we go on? You can write everything in the chat if you have any questions further on.
I will talk a little bit about soldering anyway, so you have some time to put them in place.
So don't get ready, we will wait for everyone. So.
Ja. Andi, sag mir mal bitte gleich, wenn ich fertig bin, die Nummern an. Also, I bend the legs directly at the body, and normally this is the measurement here, the grid size of the PCB then. So you can prepare this already. And you don't have to fear anything that the legs break or so. It's not the
Can
case.
be a little bit tricky if you don't put them too tight or too loose. So you have to look first. Maybe you can.
Yeah, I will show.
Put one in the.
I can show the
the
worst
holes.
case or whatever in a minute. I will prepare this quickly because in the time you will still be busy maybe with this, I can already talk about soldering in general. Okay, so I would say, Andy, let me know the numbers.
Okay, we'll start with 10K and we'll start with number R3, R3.
R3, so R3, it's this one here. Ja, 3 und dann.
Okay, R4, R4.
R4. So I make an example now.
Yeah.
If you
R5.
have if you have the leg spacing wrong like this, 5, yeah?
Yeah.
Okay. It doesn't go into it very well, like this now. But there is a trick. So you can pull a little bit with the normal pliers. Okay, next number, Andy.
R6.
6. Okay.
R7. That goes on until R12.
Okay. 7. I
R8,
found
maybe.
R8. It's there. R9 is this, I think. And R10.
Yes.
I think here. 10.
R11
11.
and R12. Yeah, I know R14.
12. Moment.
Oh, you flip. Okay.
Where's the...
So I have a picture over here.
R12. Okay, and then next
So
number?
R14, please.
R14. So what you can do is you can put one in place and then solder it, and then the next one. This is the more safe way when you're a beginner. Or you can do it like I do now. Put them all in place, turn it over, and then solder it. 15 or what?
15, yeah.
15.
16.
Yeah.
17.
Okay, we have the
19.
first questions. So, which directions are the resistors go in?
Resistors generally have no direction. We have different parts. Resistors don't have a direction. Then these kind of capacitors, let's...
Also, no.
And also, Newton Labs can't find the R4.
R4 was here. There.
Yeah.
So all these kind of parts, they don't have a polarity. Resistors and the small capacitors, and also these ferrite ones here. And then we have some parts which have a polarity, which are the LEDs. In this case, yeah, there it is. You have one short leg and one long leg. The long leg is plus, the short leg is minus. We come to this a bit later, and here.
Okay. One thing. Any solutions for bended legs? Does it matter?
Okay, wait, give me a second. Here on the diodes you have these kind of ring. In this case it's a white ring on a black body. In some other cases you have red bodies with a white ring, etc. But here the white ring is the indicator, and you find this on the PCB, on the silk screen itself here. This is the white ring from that body, for example. And the big capacitors, they have a polarity too. On one side you have this white stripe, which is marked with a minus sign on it. Sometimes, in this case too, you have a long leg and a short leg. The short leg is minus, the long leg is plus. On the PCB itself, you always have here, in this case, capacitor 4 plus and minus marked. Sometimes you only have a plus, and then strangely on this thing itself you have the minus indicator, so you always have to flip around it in your head. About bending the legs, now I come back to this. Wait, give me 1 second. I was looking for a flyer or something, but I don't have one. But I can take a cardboard, or a flyer or whatever. Oops. To put it on top, and then turn it over so they don't fall out. This is possible. So about bending legs.
So let's say if you're doing the method by step, putting one resistor in, you can hold it with the finger and bend the legs to the side and they didn't fall out.
Yeah, but the problem is, this is here, I demonstrated here. You can bend it a little bit to the side so that they don't fall out. This is possible. But please don't do this thing here, because if you made a mistake and you have cut the legs off later, you have immense problems to get this resistor out, because it has these kind of Haken, you know, Widerhaken. So it's very difficult to get it out again. I would never do this. You can bend the legs a little bit, but better not too much. So, and then we come to the actual soldering. Cut.
Yes.
I like to work with a degree of 370 or something like this, close to 400. It also depends on the solder, which solder you use. Yeah, it's a bit complicated with solder. You can read on it. You can read about it on Wikipedia. There's a long article about solder, and it's actually more difficult than I thought. So, but for our things here, 350, 70, close to 400 is kind of okay. And it goes like this. What happens actually is, if you solder, you heat up the leg of the component itself, and you heat up this kind of ring, this little area here. And the solder makes the connection between both of them. If you heat up only the leg or only the solder pad, apply the solder, but there is a big temperature difference between the pad and the leg itself, it won't be a good connection. So you have to heat them up in a way that both get equally hot. Then you apply the solder, and then it's just a thing of a couple of seconds, and then it's over. Also, there are some cases where you have to take care from which side you come, because the solder, like maybe here, already in top view, maybe it's a bit difficult to see now on the picture, but here we have two solder pads very close to each other, and we shouldn't close this hole before the actual component here is inserted later. So you have to make a decision from which side you come in solder, because the solder, when it melts, always goes to the point with the most heat, and this is the tip of the iron. So make your decision from where you come. Always come from that side to which it can flow during the process. So let's start with that. I take this, I heat up this place, I heat up the ring and the leg at the same time, and you can apply a little bit of pressure, so pressure doesn't destroy anything. It's better than hesitating too much. For example, if you hesitate like this and then you go away and you come back and so on, you won't have a good solder joint. You have to make the decision, yes, I want to solder, and then you heat up this component and the ring, you apply solder on the tip a little bit, wait for a second, and then you go away. And what you want to see is this. If this is your PCB, this is your leg coming through. If you see things like this, bubbles are super strange. Something probably is wrong. What you want to see is this kind of thing, kind of volcano shape. And what happens oftentimes is, first it melts, and then it builds a bubble, and then it sets down, and this is what you want to see.
So don't solder too fast, because they are coming the bubbles, and it's a cold.
It's a cold joint.
A cold joint, and then they have no connection. So, but sometimes you can't see it because you think, okay, that's fine, but there's not a good connection.
So you come with the iron onto your area here, heat it up, you apply the solder, you take the solder away, and then you take the iron away. Here you have two solder pads very close together. So let me check how to deal with that. Maybe I go in between them. So, and oftentimes, in the end, yeah, it's a matter of heat transfer. It's only about heat, transferring the heat. And sometimes if you can't reach a point which is further in, like here, you also can cut off the legs which are in the way. Do them first. Yeah. I will do this first row now. Cut them off then. And then go further in. Sometimes you will experience that it melts very fast, and sometimes it melts quite slow. You will notice this. Oh, I have to clean my tip. If it doesn't melt so good on the actual solder pad, it sometimes might be the case that this position is connected to the ground area. You see, for example, hope nothing falls out now. It's difficult because in the camera I can see it better than in real. For example, now here you see these traces. It's very narrow here, everything. You see these traces there.
Maybe on the left there you can see it better.
Yeah, whatever.
Yeah.
Yeah, you see these big traces, and sometimes you don't have little traces. You have big areas which are usually ground then, and if something is connected to ground, there's a lot more copper under this coating, which you have to heat up before the solder melts and sets into place. So this is oftentimes the reason why some points go more difficult and you need longer soldering duration than other points. Here we have one of these double thingies again. So, and if something looks really shitty and you're not sure if there's a bubble or something, you are not sure if this is a good connection, just apply
We
some
have
more heat.
the next question. Do you see it?
Yeah, okay. Yeah, that's fine. You can solder them together because they're so close together. They are together, so you can make a connection, or it's no problem if you have a connection about R9 and R12. So that's fine.
A quick note to Andy, you can also write in the comments here on StreamYard.
Now I have this one thing left here, which is very close to this big pad. I try not to cover this hole, of course, so means I will use not so much solder. Maybe I will come back to this solder point later when we have this component inserted then. But there's a connection now. It's not wobbling around anymore. Okay, there are, but I can't reach them, these two. I can't reach them very well. So I will start cutting off some legs. You cut them off directly over the solder joint. So don't leave them too long like this or so, because if you put it on the back, then later they can bend and make connections where no connection should be, which is scheiße. And always make sure to hold the component leg before you cut it off, especially if you work with other people. They can fly around, or they can fly into keyboards, computers, whatever. It's not nice.
Yeah, you will see if you cut the diodes, they're very thick, and if you cut them, they fly around like helicopters.
And the less sharp the blade is of your cutter, the more they fly. So there's this one leg with the it's a bit difficult point. I will leave this longer as kind of a reminder for myself to come back to this later. So, how is it going for you? How's
Looks
the
quite
timing?
good so far.
Yeah, how's the timing? Is it okay?
Everybody is ready.
Mm.
So I hope everybody having fun.
If
Well
they don't
concentrated.
react,
Be
they are
careful.
busy.
We'll wait a minute or so. So, and if you think you have an bad solder connection, maybe there's a bubble or something, you can reheat it again, so you don't need to put new iron on this point. If you're not sure, and maybe you think, I don't know if this is fine or it doesn't flow all on the silver ring on the PCB on that point.
Just heat it up again,
heat it short up again,
and usually it sets down then.
yeah.
And little trick, if you have a bubble or something that looks strange and the connection is not, you're not sure about the connection, if it's really good, you can also reheat it like I do now and add a little bit of fresh solder, just a tiny bit, because in the solder there's actually a kind of flux, kind of resins, which make the solder set down and relax, and then it sets down.
Okay, here's one he have a problem. Here's small error. How to use the pump? Maybe you can show how you work with the pump.
Sure. So our space here is a little bit limited. This
But
is
you
a
can
bit,
show it on the normal cam.
this, yeah, I don't have so much space here. So, for example, it goes like this. You heat up the point, put the pump, and then suck the solder away. And you might have to do this a couple of times. Yeah, question. Is it in the wrong position or what's the problem? Or is it just too much solder? Because that's the difference. Too much solder is quite easy to get away. To get the actual component out of the board again, it's more difficult.
So, but it's doable. But
Yeah, sure, it's doable.
uh,
I can tell you what can happen if you try to remove a component. Let's switch to the top view. So you have this basic material, this fiberglass material, which is usually something around 1.5 millimeter. And oftentimes you see you have a solder pad on this side and you have a solder pad on the other side. And these two sides, you have two layers of copper. One is on this side and one is on that side. And it means you can have a component which builds one trace to another component and then goes onto the other side through the material, goes on this side and then back. It's like 3D Tetris thingy going on here, and then comes back to this side. And this is possible through, we call it Durchkontaktierung in German, so means both copper sides are contacted through the board with a kind of tube. It's really a tube which connects these both sides. So, and what can happen if you, for example, do it this way? You hold your component, you heat it up, and then you pull. And then, in the worst case, it can happen that you pull out this tube which connects these both sides. So sometimes it might be a better solution just to cut off the component and to build little bubbles on these points and put a new component in place then. Just stack it over the old rubbish, which is still in the PCB. It's not the nicest way, but sometimes it can save you a lot of action, really. I did DIY builds by myself where I had these problems, and I think it was our own module or something, and I fucked it up so hard I couldn't find the problem, and exactly this thing happened, and it sucks. Yeah. It's always multiple ways to do things. Okay. How is it with this problem?
So no, it's
Andrea.
not really flat on the board. So
It's not really flat on the board. It's not a problem. It has to function. It doesn't have to look nice in the end. I mean, if it's not so long that it makes contact to other components or other component legs, etc., which shouldn't be, then you can just leave it. If it sticks out like, I don't know, a couple of millimeters or something, it's fine. I mean, you can also pull it through the board, heat it up and pull it through the board. But okay.
But
Solved.
sometimes when it's too long, you can hold it with the finger, but be aware it can be hot.
Yeah.
One component, and then you solder one section by section and push it a little bit.
Heat it up
so
and push it down.
and push it down. So
That's possible. Okay. Yeah. Should we go to the next resistor value? Yeah. It is these 4 resistors. What kind of value is it, Andy?
1 second, 1K resistors.
1 kilo ohm.
And we start with our 13, 14, 14, 13.
So slowly it fills up. And sometimes you have use for these old legs.
So
Actually, I think we have use for it.
Yeah,
when we use the
don't throw it away.
ferrit,
So we need them later.
these thingies here.
2 of them.
It's always
So
good to keep the rubbish. So
it's always good to have your space, so you don't mix up the components or scratch it with the hand on the ground, because it's sometimes very hard to find them.
yeah, if you
It
have
can
it
be
in the
very
carpet,
tricky. Yeah.
it sucks. Oh, there are many things that suck. Good. 1 kilo ohm. R13.
So
Let's find R13.
here are the output checks. But there are output checks here.
And 20, right?
20.
No,
As
20
well,
is
yeah.
here. 20 is there. 13. Ah, here on the left side.
Yeah. Okay. 21 and 22 are the next ones.
21 is this one. And 22 here is on the there. There it is. These 4. So now you can also turn it around like this if you're fast enough. And then have a look again from which side you come. Come from that side where you have enough space. Here it's not very critical. Easy. Here it's also very easy. Lots of space. And here we have this kind of double thingy again, there. There. One hole is still open, so we have to take care about this. But what we also can do, we can leave this open, because the component has 2 legs, of course. We can just solder one leg, so it doesn't fall out. and leave this before we close and smear this. Yeah, I believe this. And then I solder these two when this component... it's the LED, okay. Yeah, when this comes. So, and in between, always clean your tip before you have too much rubbish on it. Okay. Good. So I will leave this one. This is the double thingy.
Everybody ready so far? Give us a little check in the comments, please.
Yeah, I will start with the other two resistors. Which value is it, Andy?
Give me a second. It's 56 kilo ohms. And R1 and R2, the last two.
1 and 2.
1 and 2.
So I prepare them like this. R1, R2. Here on the top. R1.
So if you ever mix the resistors up because you made a mess or something and you don't have a multimeter testing out, there are colored rings on the resistors where you can look on the internet and there are the code for the value of the resistor. So I also had this problem. I didn't have a multimeter with me, but I mixed up the resistors and then I take a look
Okay.
on the resistors and you can...
Maybe we should
Yeah.
slow down a little bit, so
Yeah.
we have some people, they are at the resistors of 10K.
Okay.
Okay, we have one.
Now resistors are ready. And I would say we will wait until everybody is
At this point, yeah.
at this point, or almost.
Mm.
And in the meantime, I will put this here so it looks very nice. I drink a bit of tea.
Nice.
And if you have questions, now I have time to explain things. Just write.
Okay.
Okay, here,
Tea.
please slow
Apples.
down. Tea.
Okay. Little slower.
We have time. In the meanwhile, you can, for everybody who's ready now, you can write if this was your first purchase for our shop, or do you have any experience so far with soldering. Please leave us a comment and we can chit-chat about this while we wait for everyone. Andy, you're fine.
Yeah,
I can't see you.
Yeah, I'm coming through here.
Really great. How does it feel? First time on the live show.
Good, very well. Yeah, it's my first time ever on a live TV, on live show. So I'm also a little bit nervous, but looks good. We will do this.
It's
And
normal.
hopefully you learn a lot today. And if you have any questions, feel free to ask us. So we want everyone to finish this module, and it should work at the end, and you have fun with it. So
Someone was at
okay.
a super booth
yeah,
Befaco
cool.
workshop. Yes, really cool. So sad that this year it doesn't happen. So. So did you see the next Super Booth will go on and make an outdoor event?
Okay, I didn't know about it, but
Yeah, really. It's
yeah.
really crazy to think about it. And SOUNDMIT, we are really, really pleased that you make this happen for us, and they still try to give everyone a really great content and opportunities like this one. Okay, cool. Somebody knows each other. Fine.
There it is.
Yeah, there's the noise folk.
It's also available at the shop, yeah?
Yeah.
Yes. Meanwhile, we should make a little break for a commercial or something. I don't know. But
We'll take
I think
finished
everybody knows
module
the
and
shop,
ground.
and yes.
So that's what it looks like at the end. So it's very tight PCB as well. There are not that much components, but they're very tight on the place. So you also have to look and don't go too fast. Take your time, because if you're going fast, then you make the most damage. Or so.
Please remember, always hold the soldering iron in the right place. On the
Yeah, not on the tip. But I think everyone will notice if you do this.
Ich hätte hier mal kurz was überlegt, Kolben.
Ah, okay, ja.
Yeah, I use the possibility to talk about soldering irons. We use this one now. It's kind of a Chinese thing. It's called TS80. TS80P. It's very small, so it's good if you travel a lot, and so it has a lot of power. It's okay. It goes with USB-C. You need a power supply with power delivery, which puts out a lot of power. Otherwise, it's not strong enough, the iron. But I still also like these ERSA thing, which I also have it in the recommendations PDF. It works directly with 230 volts. We use this since 2015 now in many workshops, and they never fail, so it's also very good. The problem with these things is if you want to buy new tips, there are tons of offers, for example on AliExpress and eBay and Amazon and so, but you never know if it's a cheap Chinese copy of a copy of a copy, or if it's a really good tip. And we had tips which were dying very fast then after a couple of months, and yeah, I don't know. This is the thing you should keep in mind. So, and when you buy stuff from ERSA, you will still get these kind of tips in 20 years. That's the point. Okay, how is it?
Silence.
Silence. Busy silence.
About solder
That's
iron.
good.
I personally use, and solder iron had only costs maybe $50 or something. I'm not using any special high-tech solder iron. I use it every day and it works fine, so you don't have to take so much money for it. So maybe you should 40 until 100 euros are fine.
Yeah.
Feel free to pay more and to get a better station, but if you don't solder too much, it should be something about $40, so or 40 euros. And
Yeah. But they have seen the recommendations PDF anyway.
Okay, we got first ones who are already all the same. Okay, looks good.
So, same thing.
Hopefully you're at the right spot. Yes, we hope so.
Same thing with the diodes. Bend the leg directly at the body. And now this is a component with a polarity. You have this indication line, the white indication line, and you find this also on the PCB there. And where's the other one?
right where your tip is?
Da.
Yeah.
Yeah, there and there. So I put this into place. Bam. Fits. Very good. Yeah, this holds very good. You know what? I will get myself kind of a pointer. So here we have the same thing again with two holes very close to each other. So I will solder this hole to keep it in place and leave this one for the moment when we add this ferrite here. And here it's no problem. There we only have these two holes and nothing else is in the way. So let's go. Very nice, big solder pads. Thank you, Befaco. Well done. One thing I really don't like when manufacturers make the holes too wide, because then your parts are just wobbling around. You need tons of solder, etc. Oftentimes it's actually better if it's not so wide. Good. I will leave this one for later. As I said, I will shorten it a little bit. And
Okay, Andrea is still on the resistors.
We should make slowly,
yeah,
that everyone can follow us.
okay. Befaco. Yeah, I think next year we will do some Befaco workshops again. Oops. I was planning to do something every 2 months or so, an online workshop. The difficulty will be to find modules which are not so difficult. But let's see. Maybe we can also do something over 2 days or something. That we solder until a certain point and then we stop. You finish it in your time, like this, the layer of resistors or so, and on the next day we meet again and we go on, something like this.
I think this would be good.
Hmm.
So, and if
How
you
do I know if the kids on the side have comprehensive manuals like this one? I'm not a pro. And need detailed instructions. Yeah, well, just download the manuals before you buy something, I would say. and research a little bit. This is something I also do when I make projects, when I have time for it. One of the, if you really want to learn stuff about electronics, these North Coast DIY kits, we have them in the shop now. They are pretty awesome. They don't have the nicest front panels, etc., but function-wise, they are awesome. The quality of the parts is awesome, really. Only the best shit you can find. And the documentation is awesome. Just download it for fun and have a look. He has, I don't know, 50 pages PDF, and he explains everything. It's like studying electronics or so. So this is a super good way if you want to go deeper into it. Yeah, it's you can take multiple routes, of course. You can go more into electronics, or you can just see it as meditation and you solder for meditation and fun and on nice cold winter evenings or stuff like this. I always did the second. I was lazy, and I oftentimes left it to Hagen, our main engineer, to find the weak spots and to find the solutions. Yeah. When I started with workshops in electronics, I quickly realized when I want to be really good, it takes ages, and it keeps me away too much from making music and from interacting with people, like driving around and do the workshops. And yeah, so it's a mixture of both worlds, kind of. Okay, how is it? Great tip. That sounds like it's for me. North Coast. Yeah, North Coast is really super good. Not cheap, but I think really good. On Schneidersladen, they did this demo video of the North Coast BCO, which is fucking expensive. I reposted it on Instagram. You find it there. Really good sound. And complex.
Take a nip from it, probably.
Okay, should I go on with the ferrite ones?
I think so. Could you show again where they stick in?
So it's these two little thingies. And what you need now is this. Some legs from your rubbish. I choose the ones from the diodes. They are more, they are a bit thicker than the others. And then possibly I can just take the pliers and let me check it. Just bend it around like this. Oh, too much. Yeah, good. Try to make these flat again. So, and then you have this. Yeah, with the other legs, they are a bit thinner and it's easier, I think. And this has to be there. Yeah.
So these ones have no polarity. You'll find if you turn them.
Yeah. There and there. Okay. Okay. And now there is this double thingy. I will solder this now at once, like this. Okay. Cleaning up the tip. Okay, then we have this. One step further. Oh, there's one resistor. Here. Which one is it?
I think it's from the 100k. From 10k, maybe it is the last one, R19.
Or maybe it was one more than necessary.
Take
Ah,
a look.
19.
19, yeah.
Which value is it?
10k.
10k. Ah, you never know. 10k, yes. It's the right one. R19. Okay. Then I will do this one now.
After this, you can explain how the multimeter works a little bit
Yeah.
to show how you can see the values.
Yeah, this is a multimeter which is not too complicated and it's very inexpensive. Very good is this functionality here, where if you connect both sides, you can check if you have a short circuit somewhere, for example, and you can measure voltages and you can measure resistances and this kind of things, which is kind of helpful. I mean, it's not always possible to measure the correct resistance when something is built into the board. Then sometimes it's difficult because it's a complex structure of multiple resistances, etc., etc.
Okay.
But it's a very
Manu,
helpful
can you
tool.
please wait? We have some questions.
Okay. I
Yeah.
think I created a joint between the two and solder joints of the ferrite. So maybe you mean one ferrite with a diode, and there's connection.
Is it
Do you mean?
is it this one, or is it between these two, or where's the other one? There, or is it between these two? So where's the? Because this thing here, this is normal. You have two solder points, solder pads, very close
So
to each other. It's the ferrite and the diode, and these are naturally one big.
So between
Thing.
D2 and the ferrite. Okay. Yeah. Okay. They are together, so don't worry.
D2 and the
These
ferrite.
pads are close
This.
together and they are in the schematic together. So
Yeah,
you can join them too. Or yeah.
that's natural one big thing. It's the same like here, where I left these leg for later, because there we have these two which actually give one big solder joint in the end. And the same thing you have here. Yeah. This will look the same in the end.
Okay, we have it.
So, Auli, can you explain on which resistor you mean? You said transistor, but we don't have transistors yet, so I think you mean
Two of mine
resistors.
resistor joints touch. Is this bad? Yeah, it depends on where. For example, here you have the same thing. They are together in the end.
If I can
If you see it here on the back, they are together there and there. So if something is really close to each other, it's oftentimes meant to be like that.
It's the group of the four
group of
resistors.
4 resistors. Let me take a look.
This one. Yeah.
Ah,
R15, 16, 17, 18.
that's fine. So they are together in the schematic as well.
Yeah,
On the PCB, so they are joined together. That's fine. So
that's okay.
Okay, great.
Good. Then we have all the resistors done. We have the ferrites, we have the diodes. And then, next thing could be this. We have one time 4 capacitors. And then we have these drop-like thingies, which are 3, 4, 5, 6. 6. Let's do these ceramic Scheibenkondensatoren first. The 4. It's
C5, C8, C9, and C12.
5, 8, 9, 12.
5, 8, 9, 12. Yeah.
So. C5, it's there. It's quite in the middle. They are very loose. I will bend these legs a little bit so that they don't fall out. Like that. C5. Was? 6?
Next one is no 8.
8. 8. Where's?
So 8 is
5, 8. Ah, there. 5, 8. Next number?
9.
9. It's there. Maybe you start realizing now why I wrote these with the glasses. If you wear glasses, please have them at hand. We had lots of workshops where people forgot their glasses or the light was very bad and then they couldn't read anything and so. Okay, last value?
12.
12. Okay, it's there.
So Mutant had a question. The dark or the light drop thingies.
And they don't have a polarity.
Where are the dark ones? Right. Do you mean the capacitors?
The dark ones, which look
Yeah,
more... Yeah, there you see it. Oops, sorry. There, these ones. They are marked with 10. They have a 10. Okay, then I will turn it over and solder this. Here we have the thing again, or is it? Nee, that's the resistor. Okay. these two solder joints are so close, I left them. Oops. Ah, my iron was cold. Okay.
So if your solder tip is getting a little bit dark, it gets a dark ring, you can push it in the cleaner, or yeah, don't push too hard because it's damaged the tip, just a little bit. So yeah, we put the 4 capacitors first, and then we put in the 6 ones. So you can follow the instruction and put them 6 on, or the 4. We take the 4, so it doesn't depend.
So the image quality should be better than last time, right?
Really better.
Yeah, it was a bit
Last time we had some
frustrating.
little problems to explain something nearly, so this looks very much better.
Yeah, it was the first one last time. Good.
Learning is a good thing.
Then we take these drop thingies. Different value, different type of resistors. Capacitors, sorry.
Yeah. We will start with 2.
2, 3, 6, 7, 10, 11. 2, 3, 6. Okay, C2. C2, here, top left, C2. Same thing again, I will bend the legs a little bit. C2, C3. What's the next?
6.
Basically it's easy now. Because you just have to fill the empty spaces, but it's always good to cross-check it. 7, yeah?
Yeah, yeah.
Because if you made a mistake earlier, you will make another mistake. 10, 11.
Yes.
Here we have the same situation again. 2 holes very close to each other, so I will leave this for later. I will do this one first and leave this away, not to close the hole by accident. Okay. Here you have to be a bit careful too, because this is the hole for the side of the pots, the potentiometers, and if this is closed, it will be difficult to get the pots in, so I will not use too much solder here at this point. here's the one, I will leave this one and do this first. Okay, so I will cut the legs down.
So has everyone finished the resistors until now? I think we will wait some minutes.
Mm. Yeah, let's wait some minutes.
Okay.
When we go on, you see that some components are on the other side now. Resistors, capacitors, this kind of stuff is on that side. Potentiometers and jacks, the connectors, are on the other side. So we'll give you some special tips about these then, when the time has come. Hey Andy, the pot values are the same, right? It's all the same?
That's a good question. Let me look. But they should all the same, yeah. Because these are the same channels, so they are all, I think, 100k. I didn't see it on the manual, but I have it in my head. There, yeah, dual gain, 100k resistors.
100k resistors, yeah.
Potentiometers.
Yeah.
We have a question for the ferrite.
Yeah.
What's the function of the ferrite? Do you know this?
I didn't hear the question.
Okay.
Sorry.
It's
What's
here
the
on
function,
the
what's the
screen.
function of the ferrite?
Yes.
The function of the ferrite blocks high frequency from our power line. So if you have your power section and many modules, like someone with microcontrollers or something, they are working on high frequency, something about kilo megahertz and something, and you get some little noises in your power line, and the ferrite blocks high frequency. So we want a straight line power supply, plus minus 12 volt, and we don't want any small peaks in our power supply. So you have them also on your USB or normal power cables from your home power supply, and they are for blocking. So sometimes with you have this problem if you have an audio mixer or something, and you put your power in, and you have so much other electronic stuff in your house, and they making some noises, peaks in the power supply, and if you have them on your audio device or something, you can hear them sometimes. If you have headphones and things doesn't cracks or something like that, you can try and do a ferrite on your power cables or USB also, and that's what they do on their models as well. So not many manufacturers do this, but Befaco do this, and I think that's good. So yeah, I personally never had any problems with power supply and noises, but it can be. So if you have many modules on your system and you have a small power supply, it could be a problem, and then you can hear it. Or yeah.
Yeah, and sometimes it helps. I had some issues with Arturia cables and some other thingies, and these are not so bad. So maybe we can show this. This is what it
that's a
looks
good
like, the caps for the cables, and there is the ferrite inside. So if you ever wondered what are in these little plastic thingies on your cables, this is it.
So yeah, if you have problems in your studio or something and you don't know where it's coming from, little noises and cracking and all little things, you can go for that and try them. So
You can buy them separately and then make a little ring with the cable and put it through. This should help.
so in Eurorack, it's not so often on the power supply section. Will I show you later on the schematic and explain a little bit about the components. But yeah, they should help and they're fine.
Okay,
It's good that they put them on. So
we got the next question.
So, which are the two 10 microfarad caps? The blue ones? No, the blue ones.
Oh, 10. Yeah, that's right.
Yeah,
10
the,
off.
ah, okay. The others as well, ne? The 4 ones. 10 pico. I'm sorry. Yeah, the 10 microfarads are the blue ones, and they have a polarity. So you can check them here. They have the white line, and they are minus. And be careful by putting them out. Don't pull it too hard on the cap itself. So I also break some of them, and this will be a problem. So
Einfach runtercutten vom Gurt.
yeah,
Just
I'm careful with that because I damaged some of them.
Einfach runtercutten. Wieder über den Gurt abcutten.
Yeah,
Klar. Dann hast du
I'm
zwar
doing
nicht mehr
like
den
this.
Unterschied, aber
So yeah, okay.
so hast du vernudelte Beine.
Yeah. So you can also see the short leg are minus and the long leg are plus on the, but it's easier to see on the white stripe. So you have this also on your PCB. Where it is, boom, 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 boom. You will find it. I find it not.
Und irgendwo unten.
Where the caps? There. The small circles. And yeah, they're printed a plus and minus on this. So
Ja, hau die rein, Junge. C1 and C4.
C1 and C4. There it is. So I'm left-handed, so iron has to heat up. All right. So I have to be nearer. I can see it right now. It's in the picture here. So that's it. So you can also take a look on your PCB. Is every connection fine, or do you missed something? So we have this with the orientation where we didn't solder them yet because they are too near by each other. Oh. But you can look if you have someone too small or doesn't floating solder point, but it looks fine. So I will cut my legs on the capacitors. Und
Gleich noch das Papier ab. Eine Rumpel nicht im Bild.
Okay, how does it look, everybody?
Hier, wir müssen jetzt eine Entscheidung treffen, was wir zuerst machen. Wir könnten die draufwamsen und dann die von der anderen Seite. Man könnte die ja dann auch von oben soldern, ne? Aber dann liegt's doof. Aber wenn wir die Pots zuerst machen,
das kommt.
die muss man aber leicht erhöht reinbauen, so wie ich mich erinnere, oder?
Nö, das sollte eigentlich so funktionieren. Bei dem ist vielleicht nicht schlecht, aber der sitzt ja auch drunter. Wir müssen aufpassen, wir können nicht die hier erst die Pots drauf machen und dann die draufhauen.
Also
Weil wir
erst
sonst
die,
nicht mehr drankommen. Eigentlich erst die Seite fertig machen. Das ist halt ein bisschen tricky.
ja,
So, ja.
machen wir erst die.
Erst die Sockel.
Ja.
So.
In the meantime, if anybody has a little bit spare time, you can watch our Instagram channel. So there are some cool modules and what we have in stock and all the things Manu does in the meantime when he does not on the internet the workshops. So, and he can't hear me. That's fine.
No, I only can hear you. But we will go on. Yeah, I
I
we
think
will
so.
go to back B. We will solder the power connector right now. It's in the back with the potentiometers. Pull them out. This one and the small one. So I think we will start with the big power connector. So we will turn it around, locate it here, and here you have a little mark on the PCB where
Can you show it from
shows
the
you-
top?
Yeah, I'm sorry. Yes, so. Can you see it? Here you have a little mark, and your power connector has to be in there with this mark here. So don't turn it around because your cable connector will be on the wrong direction, and that will be not so good because we then have the polarity in our power supply changed. So look to the mark, see there, and then we can turn it around. So I will do this so because this is a little bit flipping and you don't know if you solder the legs if it's flat on the PCB. So I turn it around, solder one leg,
Yeah, you can do one corner first, then verify if it's really even.
So,
And then you still have the chance to correct it, because if you have 2 or more of them soldered, then no chance.
yeah. So I soldered one, and if it's not fit like this, I will show you. So there. So you can see it here. If you solder them and it's flipping out, and you have soldered too many connections, it's hard to get it in. So if you just only soldered once, you can put your finger on it, make the solder point hot again. So push it on the PCB, and now it's flat. And if it's good, I will solder the other ones.
Can you please tell Manu to stop eating chips?
It's a carrot.
Möhre.
Eine Möhre.
Ah, Alter, das ist schrecklich.
So that was on the power connector.
Yeah. So polarity is important on this.
Yeah.
Because otherwise you have the plus and minus flipped.
We have some questions here. One is the LEDs are not soldered
yeah.
in now.
The LEDs are for the other side, so we will finish the one side and the LED will come after, and you also have to be aware of the LEDs. That's the last one that they that's soldered, because they have to be flat on the front panel, and if they're left and right, you will see that will be a problem. So the LEDs, you can put them on the side, and they will be the last ones.
Yeah, and the next question is the triangle on the shape for the power connector. Is this the sign
yeah,
you
now it's closed, but here on this side there was a little square. On the big square, a little square, and that's this mark here, where it's a Kelbe.
That's the notch.
A notch, yeah, a notch. You can see it from here. So if you're not sure, maybe you have the manual out, and on the last side there's a picture on the PCB, so you can look. Okay, I will do it slowly the other connector. So this one has a plastic on the side, so it has short and long legs, and these are coming also on this side on the PCB. And
Das ist die
Also,
Position von der.
sorry.
Da kann man es in beiden Camps
Ja.
gut sehen.
So the short legs are the one you put on the PCB, and you always can locate this on PCBs where you have to put them in. If you don't know it's on the back or on the front side, they show you with the silk screen. So here is also a square, and this means we have to put the short legs on this side on the silk screen or on the PCB. Should look like this. Then I will turn it around, put my fingers for this. Oh, so I lost it. Okay, do it again. It's easier if you have a cardboard or something to flip it and hold it. So I will hold it with my left hand and hold desolder, so it can be very tricky. I soldered one leg, lift it up, and now you can see there's also, maybe you can do the other camera. You can see there's a space between the plastic and the PCB. So I will look where I put my solder joint. It's here, so I will put my finger on it, but not on the point, not on the pin where the solder iron is going, because it will be very hot. So I heat it up for a second. Push it in, and now it's flat. So this can be very tricky, so take your time, and then you can solder the other ones.
It's kind of easy to remove a resistor or something like that with 2 legs, but it's super hard to remove something with more than 2 legs from a PCB once it's soldered.
After that it should looks this. So do we have a comment right now for something?
Yeah.
Okay.
No, everything
I think
looked fine.
everyone are soldering right now. So I think we are finished. No, on this side.
Okay, which hole is it? Hmm?
He's on the ferrite now.
And there's solder stuck in a hole.
So maybe you mean it's stuck on the ferrite solder? The one next to the diode one.
I mean, is it inside the hole with no component? Ah, okay. Was it melted or is it just sticking in it? What if it's not totally flat?
I think you mean the
What
power
is not
connector.
flat?
If the power connector is not totally flat, it's not a problem.
Nee. As long as the pins stick through the PCB and are soldered properly, that's no problem.
It's belted and blocks the hole.
So you have to heat it. Do you have a pump?
Dim, 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 dim.
No, you're fine. Sadly not. Okay.
Okay. Then I would say, which is the hole? Which component comes through it later?
Ferret was by
Ah, so you don't have, the ferret is not in place, but the hole is closed, right? Because then I have a solution.
Mhm.
Yes, okay, good. Then I would say, put the, so, it's, I fake it now, right? It's not the hole of the ferret, but it's another one. I would say do it like this. Heat it up from the back so the solder melts, and then take this leg, which you will need anyway for the ferret, heat it up, stick it through the hole a little bit while the solder is hot and liquid, and then you have soldered this one thing first, and then after it you should be able to put the ferret over it. Then you can bend it, possibly something like a pliers is a good thing then. Put the other side somehow into place into the other hole, and then this could be a workaround to do it like that. Because if you have no pump, it's very difficult to get the solder out of the hole. But this could be a solution then. Yeah.
So if it's not very melting, with you have a little solder in the hole, and it's not melting, if you try it like this, you can put a little bit more solder on it. Then it's
heat it up with a little bit of fresh solder, like I told before, and then new flux comes into place and make the solder liquid again and move more smooth. So that means you are still busy with the ferrit ones. Means also you didn't have these. Oops. Means you didn't have the boxed header and this kind of header thing, the pin header. Should we go on? How is it with the others?
Maybe we can do a little Jitsi talk after this show. So if anybody has really stuck on it, we can solve problems in the after chat
Yeah, also
to
possible.
stretch it not so far. And you
Mm.
can always look on this stream afterwards and go on.
Yeah, let's do it. Okay, then we'll do this. The IC sockets is this thingies. The actual ICs, integrated circuits, look like this. And of course you can solder them directly onto the PCB, but it's more comfortable if you use the holders, because then you can exchange them later. So the ICs themselves, they have, sometimes they have a notch on one side, like you have it here on the holder, on the socket. There's this notch, and on that side there's no notch. On some ICs you have the notch on that side. Sometimes you only have this dot kind of thing. It's there. This is the indicator for the direction.
I think at this point we can do a 5-minute break to ask of a short break. Maybe we can do a coffee or so.
Yeah. Break before this or after this IC sockets?
I think now it's a good time to make a break and then go on. I think this should be enough time to have everybody on the same page.
Yeah, okay, good. We drink some tea and be back in a couple of minutes. Then let's go.
So, in the meantime, for everybody who's waiting, please be patient for everyone, because we're all a small group today, and hopefully everybody has fun right now. So, if you like, you can tell us some stories for those who are finished now, and tell us how you came to soldering and DIY. Maybe this is a good place to chit chat for a few minutes. And if I'm not wrong, I see two ladies today, Annie and Andrea, maybe? Okay, Annie seems to be an girl, and Andrea is an Italian man. Ah, great. Is this your first soldering project, or everybody is Okay. Seem we can go on. Yeah, is this your first project in soldering, or are you done some other projects before?
So, should we go on
Oh,
right now?
slowly.
Is everyone?
The first project.
So yeah, if you placed one IC socket the wrong way, it's not a problem, but you have to be aware that you put the IC on the right side. So maybe you have to took on the manual. So it's not a problem to change them, but these little notches are your location for the IC. And if you change them, you can also change your IC fast and didn't notice that, and then you have a problem. So the socket, it's not the problem, but it helps for the location.
Sometimes, let me check if this is in place. Yeah, you don't see the orientation anymore
So
if this is in place. I would say a good thing would be then, if you know you did this one thing wrong, when you have a white marker or something, Lackstift, and you make a mark by hand somehow on this position. Like here you see the notch. Here you see the notch, and there you see the notch. And this is a typical failure. If this is wrong and you swap ICs later because you want to repair something, or you put it the wrong way, and then bam.
then it smells bad. Yeah.
Okay.
Okay.
So I think
I
everyone
see.
is ready. Yeah. So I
Yeah.
will go on and start with the IC sockets. So we will put the IC on the side. So let's have a look. I will start at the end here. Put them in. So now the capacitors are a little bit higher, and the box socket as well. So I will push it, and I will take this part from the IC to hold it a little bit, so it will be in place. It's a little bit sided soldered, but it should be fine. So the iron has to warm up. Just a second. Oh, it's melting. So, soldering one pin, and then I hold it, soldering again, push it on the back, but it was fine. So I can go on for the other pins. Clean my iron. So looks good, and then we have to go on. Next socket. Need this orientation direction. So I'll use this one. Push it. looks fine. Alright, the last one. Oops. So, new round of solder iron. So, that's it. So, looks well right now. I think I was a little bit fast, so I will wait for some seconds. Because the next part is a little bit tricky to put the ICs in. So I think we will start this, or yeah, we can do it at the end as well.
Würde ich machen.
So okay, we will put the
haben wir
ICs at the end.
Jetzt haben wir erstmal die Thonkies und die Pots, ne? Mit dem Panel.
So, ja, wir können mit der Frontplatte starten danach. Mit dem Platzieren. Und genau, dann die drauf machen.
Okay, haben wir jetzt alles, oder?
Wir sind...
Okay,
So.
only seems to be yes, problems still with the ferrite.
So you can't still fix the ferrite. Okay. So do you have a tool like this maybe? You can write in the comments if the ferrite isn't in yet, or 1 point, or yes. Okay. So I will take one of the old ones, the old pins, like we explained before. So if you have a solder point that stucks, lay it on the ground good so it stands, and then maybe you need some new fresh solder iron on your tip so it's liquid, and put more on the socket where you have the problem with the ferrite, and then put your tool and the pin, an old pin that you cut it off from a resistor or something like that, and then do some solder iron, make it fresh, make it hot, and then try to pull it through the hole. And if it gets stuck but it's not through, you can heat up the pin itself. So maybe you have to it takes 5-10 seconds or longer to get this point so hot that it's going through the hole. That's an idea to get your pin through the hole or get it out.
Another thing, if you have a closed hole, another idea is to use a Dremel, kind of a small drilling machine. This is something I oftentimes did. You have to be a bit careful and not to ruin this Durchkontaktierung to the other side, you know, this
The
kind
vias,
of tube.
they call
The
it,
via, genau.
Hmm.
Not to ruin the wire, but that's possible.
So I think with some new solder iron on your tip and on the point, it should go with like the method with the pin.
This-
or you can
I
do
think
some-
he has it. Okay.
This is the other method. This is the hardcore method.
We can't see it.
Oh. There.
It's a drill for PCB manufacturing. Yeah, years ago we did all the PCB boards by ourselves, etched it by hand, manually.
Good old days.
Then we needed this.
So, is everyone ready? Then we'll go to the back side, or better to the front side. So we'll need the other components, like the funky kongs and our potentiometers. There. This one. So they all the same values, so you don't have to any problem to mix them up. So here on the side, here are the potentiometers. We will put them in. So we have to look underneath the potentiometers. We have our power connector and the other pin header and the IC sockets. So they are soldering points, and we have to take a look if we put them in. So I'm doing it first because sometimes if you have them in the back, they are bended a little bit. So I start to put the potentiometer with the small pins in the holes, and maybe you have to pull it a little bit sideways if it's a little bit bended, but not too hard to bend it over. And if they are stuck, yeah, then you can put the big ones after it. So I personally have sometimes the problem if I put the big ones first and then the pins right through the hole, they are bending because they don't fit in the hole. So you better start with the small ones and put it down and push it flat. And now we have to look if it's enough space between the pin headers and all that stuff, but that looks fine because it depends on the circuit. Sometimes the potentiometers, the chassis, are grounded, or they are doing a connection. They can do a connection between the pins. So in this area, the next one where our power connector is, if there be a connection between the power pins, that will be bad for your whole system. So
I mean, what you can do if you want to be really sure that you don't make a connection with these kind of pins and the back of the potentiometer is to place some tape, for example, in this area. Oops. This is possible. The other difficulty with these pots is you can put them so far in. Can you see that? Yeah, that they are not even anymore. So now you have the correct angle. If you push them even further, it's too far. So then they are not even.
Yeah, we can show.
Oops. Oh. So they have to be a little bit like this and not too far, because then the knobs on your module will be not in a 90-degree angle. So, but we do this in the next step with a front plate. Don't solder it yet. Put all the potentiometers in place, and then we put all the connectors, the audio connectors in place, and then comes the front panel trick.
And the LEDs. So, but I think we have to bend our pins, because we then have a problem with the front panel. So I have to solder the pins right now. I'm doing it carefully, because if we put the other components and the front panel above and solder them, that could be difficult. So we have to solder them. So I think if you have done so much solder joints right now, you should be a little bit better. Carefully. So there is the last one. So try to do it not on the side where the other hole is. Do it from the other side, and just only go with your iron on the tip, just a little bit. Better you do it 1, 2 or 3 times, and then you're fine. And don't solder the other holes.
Yeah, always come from the side where you have space, where the solder can flow to anyway.
Alright. So, okay, we follow the step, putting the components in the holes. So I will do the LEDs right now. So take a look, the short and the long leg. The short leg is like the capacitor, the minus, and the long is plus. So we have to locate the LEDs, and there you can see the orientation. The LEDs are the little joints where the silk screen is around, and there's a plus. So we have to put the long leg where the plus is on the silk screen. So let it fall through, that's okay. Do the other one. So it's a little bit tricky on the PCP to locate the LEDs, because there are so many joints, many holes from the PCB. So next step will be our funky cons. So put it on the side slowly, that it didn't fall out. So we will put the banana nuts on the side. So you better put your front panel nearby you because we will need them in the next minute. So this can be a little bit tricky. Sometimes they fall out and you have to put them in again, but you have to put them slowly on your PCB. So this pin is on the PCB is a little bit nearer than it's on it component itself. So you better go with the outside leg in the first hole and push it a little bit to get it in the others. Yeah. So that's a little bit tricky, so I have to. So yeah, you can locate them because they are the two. You can see the silk screen here from the Funky Kong, and they're both holes. They are near together, and that's the other one. So now all the components on the PCB, and now we have to put our front panel in place. So we have to get
LEDs drin?
Huh?
LEDs? Kann man auch im nächsten Schritt
L-
machen.
LEDs are
Okay.
right there, yeah. So we put the front panel on the PCB. You have to little bit push it left and right.
Basically, there are two methods. You can solder socket by socket. But if you're not, that's usually no problem when you are able to solder it very accurate and flat onto the circuit board. But if you want to be really sure that they are all even, then you can choose this method, because if there is one potentiometer or socket which is not in line with the others, you have a problem to get the panel on later. This is the thing. I almost never do it this way because it's, I don't know, it's differently difficult. But for most of the people, I think it's a safe way to do it like this. Many people do it like this.
So yeah, I'm doing PCBs for years right now. So but I'm doing this way. So yeah. Also, you can see I messed up as I put the front panel on the PCB. There was two jacks there jumping out from the hose, so I have to put it in. So if it's too tricky for you to do it this way, so I learned it this way and I done this for years and I'm fine with that. You can do it like this, or you can solder the Funky Kongs first, but be sure they are flat. So these are not that problem to solder flat, because they have enough space and place to get on the PCB. But never solder any potentiometers or something like this before you
yeah.
put the front panel in.
Yeah, it depends. These ones are tricky. There are these other ones which have these kind of feet, you know, where they sit on. You know them? The other ones? They have these pins which go the whole
Yeah,
through.
yeah. Okay.
But for example, if you use these Alps, which we use,
Yeah.
there is a defined point where they sit on the point, and you can't mess it up. This is easier.
Yeah. Yeah. Some potentiometers are different. So I knew it from the hex mix that I've done with the Befaco and the hex Panda, the really big one output module from Befaco, and that was a mess to put the front panel on because there were, I don't know, 20, 30 potentiometers, and they have something like that, and you have to be very carefully to put them on. And so yeah, okay. So I will take it near by me because I can't do it like that. So now it's fine. The front panel must be flat on the funky kongs and the potentiometers, and to hold it like that, I will use these nuts or the banana nuts from Befaco and screw them on. Normally we have a tool with us in the bag, but I don't have it on the table right now, so I will do it with the hand. So if you screw them with a tool, don't screw it too hard that it bends or something like that. So if you have a PCB and you have one, like the manual says, you have to put on some point the front panel on, and then put it back to make another connection or something like that. You can only do it with with some connectors to hold it down, so you don't have to do all of them. So, but we can do it. It's not a problem. Or so that should be fine. That's good. So now we need the other for the potentiometers.
Okay, Mutant has a problem with a bad LED.
I have a problem with the LED, yeah. Okay. You have to put a hole again into the thing. So yeah, I will wait a second and do slowly after slowly. I'm just fixing the rings for the potentiometers. I hand screw it very soft.
Okay, the problem seems to be solved, and
Okay. You're fine.
only if you can't go fast enough, it's no problem. You have all the time in the world, and pause the video, and you can go on in your time if you like. It's no problem. And if you have further questions, you can always ask us.
Yeah. So I will do slowly. I put the other one in, and then we can go further. So if they use this tool, it must be easier.
I think we have some tools already.
Yeah, there it is. I didn't find it on the table, so we have
They're so black.
the exploiting chat
Wird ja mitgeliefert.
tools. Yeah, or I said the Befaco one. You can use this, or our tool you can find on the shop.
They are
Makes
handmade.
it much easier. Okay, any questions right now? No.
Everybody feeling good? No burned fingers or so?
So if you're on this point, you can feel a little bit on your potentiometers if they are turning around with no scratches or something. And mine, it feels fine, so it turns around. They are flat. The PCB doesn't look any wrong on the front panel. So on this point, it's up to you if we solder the potentiometers and the funkis right now, or we will put the LEDs in place. I think we will put the LEDs in place to not solder them and forget to put them in place. So I use this method to take a little bit of my Tesa here, something like that. Push it on the front panel, so it sticks on the front panel. Then I turn it around and push the LEDs a little bit on the front panel and feel it with the other finger if it's coming through the front panel and if it feels okay. I'll let it there. Do it the same with the other one. And now I will start basically with the LEDs to solder them, and then I can put also the sticky thing from the front panel, then it looks fine. But be aware, should be anything in place, so don't solder before you if it don't fit with the front panel and PCB. To turn it around to get there. It's really tight on this PCB. So the LSD should be fine. They are soldered. I don't cut them yet to check them if they are in place. Yeah. And now you can see they are flat with the front panel. So this is a good method, or you can also use and hold it with your finger only. But if you have something that sticks on the front panel, it's, I think, the best way to put it on. So you get really flat LEDs on the PCB. Sometimes with other modules they have the round one, and they have a little ring on the end so they can't fall through, and you only have to push it on the front panel and that's fine. But in this way,
especially with these ones which have a flat head, it's really nice if they're totally even with the front panel. It looks really sexy.
I think looks cooler.
Yeah.
So now we have gone to all the other stuff, like the potentiometers and the funky cons. So there are many solder joints right now, so I will start on one area and go up and up and up.
Can we
Don't
check
lose
again
them.
if there's enough space under the potentiometers? But it's okay,
So,
huh?
yeah. So I think if you put them flat like that with the front panel together, they are not bending to any side, and then they don't have any connections to the
With the
power connector,
power connectors
and
or
so
any
on.
other stuff which is sticking out under them. But looks good in this case.
Yeah.
Okay.
But be aware, if you pushed it a little bit too hard, take a look and look if there are any connections or so on. And if you're not sure and you're not at the point right now, you can also use the method with something stick on the back side of the potentiometers if you're not sure. But that looks good in this. And
Yeah,
you
I mean,
can go over.
also the nuts pull the potentiometers up against the panel. So that prevents these falling down.
As I said before, don't screw them too hard to push them back out of the PCB, but push them a little bit, and then they go straight.
Yeah, you see they fit, they align absolutely with the front panel. Okay, let's solder the thing. Make it work.
So this will take a time a little bit, so I will cut my LED pins off because they're in. So to solder the first potentiometer, the potentiometer has these big pins as well, so they are not necessary for the for our connections on the PCB, so they are just to be in place. And if you solder them with the normally pins, they are connected to the PCB, and for our circuit, then it's also be fine with bending if you push your potentiometers while you make music. So they don't have a function, the big ones, so you don't have to solder them because they are also nearby the IC socket. So I think I can't solder this one or this one, and not really out this one. So you don't have to waste your time to solder them.
I don't know how it is in this circuit, but generally sometimes signals can also be sent over the potentiometer housing, like ground signal, you know, connecting two ground
Yeah,
planes.
yeah. This
So I don't know how it is here actually, but I wouldn't say generally that it's not necessary to solder them, because sometimes they have a function to
Yeah,
connect two areas of the PCB with each
Mm.
other. Yeah,
So yeah, you're right. If
we
you can
oftentimes
solder
did
them.
it, especially in the time when we used one-layered PCB, you know, with
Mm.
copper only on one side. Then we had to do kind of tricks, like
Yeah,
building bridges somehow.
Yeah.
And but I mean, this is professionally made PCBs with wires and so on, where signals move from one side to the other through these smaller wires, which you actually can't really see. There are a lot of them, but you can't really see them.
So if you take a look, also no, they are not connected. I think the holes from the funky cons. No, they're not. But every hole we can see it's going through the PCB and comes out from the other side. And he's right what he said. Normally I'm also soldering the big ones, because they can have a connection. Mostly it's not, but
Yeah,
and
mostly it's just for holding them.
it's just for holding the potentiometer, and in this case, in this case, I don't think they have a connection. So I know they have no connection, but they are so near together.
Yeah.
It's also not possible. So
Well,
we
let's
had
go.
it. Yeah.
Make some smoke.
Smoky.
Burn this thing.
So this can be very tricky. So I had a connection between two pins. I don't know if you can see it. So I've soldered too near on the side. So here's
Ja, wenn es hochhältst, geht's aus dem Fokus halt.
there's a
Right.
little bridge. So I took my solder iron between them and push it to one side, and then it should go fine, or push it upward. So then there's no connection.
Yeah, sometimes the liquid solder follows the iron, follows the hottest point. So, and then in some cases you can fix these short circuits
Turning a
just
little bit the iron.
just by leading the solder somehow without any further tools like the pump or so.
Alright. Here's one of the funky.
Ist ein bisschen aus dem Bild.
So here's a little bit tricky because it's between two capacitors. Don't hold it near to the capacitor because it can heat up and get in damage. So always look where your iron tip is going through. Let's take a look where the next potentiometer is. Yeah, here it is. So the next one here is really tricky because it's between the power connector. The power
Okay,
pin.
we need a little break. We have some questions. Does it matter if the ferrite and diodes touch the solder? I don't know. I think no.
If you tell me on which diode you mean, then I can say if it's a problem or not.
And the other question is here on the screen.
T11 and the mini check close to it. C11, moment. So you can also look on the manual from the Befaco Stereomix. On the last side there's a big picture of the PCB. So you said between 10 and the FunkyCon, yeah. So I don't have a connection between C11 and the FunkyCon, but on the thing it's right, so I will check it for you. So on the picture on the manual it looks like it's together, but we can measure this out. So I don't have this connection, but is there a connection? It should be. So, yeah, okay. If you have a connection, that's fine. So they are two together. That's not a problem. Here on C11 at this pin, you mean? I think, yeah. Show CL. And if you mean the diode 2 and the ferrite, then it's fine if there's connection between them. So if it's this one, so they're also together. So I will go on with the soldering. I will do it on the boxed header. So in my case, I will use my box to hold it in place. Then it's a little bit easier. But I don't know if you can see it right now. It's good. Focus, but you can help yourself with some other things. So it's flat and easier to solder. So just only the camera is on the way. So there is one left. I don't have the best position right now. Ooh, that's tricky. So I have to take it in the hand. My hand. All right. I burned my boxed head a little bit, but that's fine. So up to the other parts. So now there are the last 2 potentiometer left, I think.
Okay, we got another question.
Mm-hmm. You're fine if you solder just the small ones. The 2 big ones you don't need in the circuit. But if you can solder, it's up to you. But they're so close to the IC socket. Sorry, was out of the picture. So it's so nearby the IC socket, you don't have to solder them because it's very, very tricky. I also had problems to solder this potentiometer near the box header, so you have to be very careful. And in this circuit, you don't need to solder them. So I've gone for my camera light. So my iron feels cold. Yeah, it's out. It's off. So it has to heat up. So sometimes if I don't reach some solder point, I turn your PCB around and look if you can make it from the other side easier. Here I have also 2 pins together and try the method to pull it out. Heat it again. So here it sticks very hard. I have also a pin connection, so I will use my pump. If you don't have a pump, you have to go on and pull your iron a little bit up and it will follow you. But if we have this pump, it can be much easier. Ooh. There's a bit of connection.
Also du bist mittlerweile komplett immer aus dem Bild raus, ne?
Ja, aber sonst kann ich den nicht richtig löten. Ich will im Bild nicht hinkommen. So. So. Now we are fine. So now I will have a look if we soldered any component like the potentiometers, the funky cons. The LEDs should be fine. So I will look for some seconds. So yeah, maybe here, I don't know if you can see it, there's a little bit of connection. There's no so much solder iron on this pint, so I will try to heat it up again, and if it don't flows too much on this point, I will use a little bit more solder iron again. And now it should be fine. So yeah, we're finished with heating up the PCB. The last step now were to put on the ECs on the PCB. I don't know if we should wait for a second for the other ones, they're faster, or...
What? The ICs?
The ICs, yeah. So it's
Yeah, I'm sure we have to wait for a couple of minutes. And then when everybody's ready, we show how to prepare the ICs and how to put them in place. Und dann können wir auch nochmal mit dem Multimeter Short Circuit checken.
Ja,
Ob
ja,
der
das hab ich
Power,
dann.
ob da irgendwo ein kurzer drin ist, wo was dran hängt.
Ja, ja, auf jeden Fall. So what we have left, only the caps for the knobs, the cable and the screws.
Looks good so far, and I hope everybody is feeling fine and had a success so on with this. Chat is pretty silent now.
Yeah, I think
Everybody is working hard.
Everyone is working and thinking. And but that was also very tricky to put the components on the front panel. So I will put my knobs on. While you're working, that's not a problem. So if you put them in, mostly the potentiometers are on other directions. I also put them on the left side, yeah, and then look on the white stripe on the knob and put them in place where here the marker is, and push it down. So they are very tight. You can push them very hard if they are in place. Well, don't push them through the end right now, but maybe you have a problem and we have to open it again. So that's our finished module. We will wait a little bit for you.
Woohoo!
Yeah, we do not forget our RCs, so that's the last part. Yeah, it's not the easiest build you can find. It's very tough with this with the space on the PCB. The component itself, it's not that difficult because you don't have too much resistors and too much capacitors and so many things that are polarized like the electric capacitors right there and the diodes. But you're right, it's very tricky with the space, but hey, if you've done this, it should be not a problem to go further and try another build. So yeah, it's a good point to take a look. What do you want to build? Which modules are there, or which companies they doing DIY kits, and look first at the manual or on the building instructions how difficult it could be to put the components on. I think on the shop we have also ratings, what is easy, what is difficult.
Yeah, sounds great. Maybe you can tell us, do you need more help? Do you need more videos about soldering and soldering modules and stuff? Please leave us a comment, and we will try to make much more in the next year.
Oh, Mutant, you was a stop too far. We don't have put the ICs in the PCB yet, so this will be the next step. So
Okay.
maybe we can go on.
Mm-hmm.
Yeah, I hope everyone is seeing right now what we do, because it's also a little bit tricky sometimes to get the ICs into place. Maybe I will explain my method. Maybe you have another one. So
ich wende die auf den Tisch.
So the IC itself has bended legs a little bit, and often it doesn't fit perfectly into the socket, or mostly it doesn't fit into the socket because it's more bended out than the socket itself. So first of all, we have to look at our location on there. Maybe you can see it. There's a little
Orientation.
There's a little point on the IC, and we remember we have our orientation on the IC socket with this little notch. And one method is to put the IC like this and bend it a little bit on the table, something like that, but not too hard. Then it's more straight through the IC. We need the other camera, yeah, there, so I can show it from their side. So I take it and push it just a little bit that it's bent more flat. If it looks like that and you don't have bended one pin too hard from the others, then you can go on the PCB, watch always the location, the orientation, And then to make it a little bit easier, I go first on one side and look if the pins are going in the socket, but don't push them yet. I turn it around. Check it 1, 2, 3 times. And if I feel they're going in, then I push them a little bit. And now they're in the socket. So this can be a little bit tricky. Don't push them too hard if you pull them, because if you bend them ICs too hard, they can damage. But if you're doing slowly, then it should be fine. So that looks good. The pins from the IC fits into the holes from the socket, and then push it one last time. So if it's not good and one pin goes out from the socket or so, I use mostly a little screwdriver to push it slowly up from the socket, to bend it again and push it back into the socket. But it will get harder if it's bends one time and it's going outside like that, and it's going to the other way, and you push it back, then you get a little curve or so, and then it's hard to put in. So really take your time with bending that.
When people sent us modules in the past where they had problems, or they said it's not properly working, etc., oftentimes it was that the ICs were placed the other way around, or just simply not completely pushed into the socket. So that's quite a usual mistake for beginners, I think.
So they are not completely flat on the IC socket. You don't have to be aware of this. If you push them, you feel that they are in, and then they should be fine.
Yeah, the point is the notch.
Yeah. I think if you put them in the wrong direction in and power this module up, the ICs will be damaged and you have to replace them. So always look on the manual if you put them on the right, or take the right silk screen. So, alright. I think we wait until 1 or 2 are ready, maybe. So yeah, Andrea, the orientation is the point of the side. Sorry. Yeah, you're right. The orientation is on the point on the IC, and where the small hole on the IC socket is. So in this case, if you see the module like this, here is one, it goes in this direction, the next one is going up, and the third one is also going to the right here.
Yeah, about the 6-pin connector, the mixer is part of this hex mix system. Befaco have this really big mixing system, big and expensive, but super geil, and you can connect it to that system.
So yeah, it's, I think it's an 6-channel mono output module where you have can also put an VCA. There's the Hex VCA from Befaco as well. It
Yeah.
also works as standalone, but it also works with the big output module like the Hex Mix and Hex Pander. So you can combine them together and make
It's
a
a
bit
complete system, yeah.
Hmm.
There's something standing in the manual, so you can read something about it in the manual, in the user manual of this Stereomix.
So, if we have time, we can look on the schematic after this to explain you a little bit. And
Yeah, I would say let's do the test first for short circuits,
Yeah.
and then try to power it up, and then if we still have time and room, if people are interested,
Yeah.
we can go a little bit into the schematics and the functionality.
Okay.
But let's finish one thing first, I would say,
Yeah.
and then
Okay. I also said Henrik is ready. So, if you have a multimeter, then it's good. So we will look if we have any bad connection on a power circuit. So if you have a multimeter, you can check them with your sounding peeper. We have 10 pins on a power connector. They are slightly both together. On the left side, let me think, it's plus
It's
or
plus.
minus. It's
Yeah,
plus.
this is
It's
plus.
plus 12 volt.
Minus is where the white stripe sits. This is
Ah, yeah,
always in
that's-
Eurorack. White stripe is minus, so never mess this up. I mean, that's a reason why I like these boxed headers, because basically you can't make something too wrong. The orientation is defined.
Yeah, if you
So-
put them
Yeah, if you put
the
them
right side in, so
Yeah.
then you haven't any problem. So sometimes you have these open connectors on some point, and you have to take a look. And
yeah,
here
that's
we
more
have
difficult.
we have also our white stripe, and this means that there is the minus 12 volt.
If you want to read something about the basics of these Eurorack bus, you can go to the Dopfer website, and they have 2 articles about mechanical basics and electrical basics or something like this. And there you find the basic pinout of this connector. So, which is basically always 2 pins in a row are the same polarity, which is plus, then 3 times ground, and then 2 times minus where the white stripe sits. So, and now Andreas will test if there's a short circuit between plus and minus, between minus and ground, and plus and ground. So, and if there would be a short circuit somewhere in the entire circuit, it would just beep.
I don't know if you can hear it. You can also use the ohm meter. Maybe you can see it. And if there will be a short connection, so it will go to 0. Now we have O and L, like
I don't know, overload.
overload.
What is- I don't
not
know.
overload, but
Too much.
Too much. It's if you put them together, you can see there you get a 0
it goes
or
to 0.
maybe 0.01 or 2 ohms, and that's like a short connection if they are connected together. So we can take a look, and we don't have any connection, and we are fine for the power section first. So we don't have any short problems right there. So
Yeah, very good.
So I think we can try to power it on.
Yeah.
So look carefully. Sometimes you have from your from cutting your pins from the resistors or something, they're laying on the PCB. It happens to me one times. I powered it up and it gives a short connection. and I had a little pin on my PCB, and it didn't short connection. And we don't want that, so we take one last time. But it looks fine. So we take our power connection and look if there's something coming.
So the thing is, you only have the LEDs lighting up when you have an
A
actual signal on the input. Means
But when they're lighting up, when it's no connection, then it could be a problem. It could be a short connection between power section and the LED, or a short connection between their IC.
Okay, can you please explain another time, once again, how to test it?
So yeah, the best way to test it is to try it out. The module. Oh, you mean the module? How to test it?
Yes.
Yeah.
you mean test for short circuits and that stuff. Yeah,
Okay.
like before powering it up,
Sorry, I was 128.
it's the easiest way is to use the multimeter with this beep function, as Andreas did. And if you connect both pins, it beeps if there is a short circuit. And if you have a short circuit between, on the power header, between ground and plus, or ground and minus, or minus and plus, etc., and it beeps, then you have a short circuit. And then you have to do research, I would say, for the mistake. Where's the mistake? And we checked it. We didn't have a short circuit, so we are quite sure it survives when we power it up. And now we did. And the Eurorack is still running. And the module, there's no magic smoke, so it seems to be okay. So now we could try it with audio. So this should be the output.
Yep.
Guckst du Kamera ein bisschen? So, and there should be audio on both sides, right?
It works.
Ich hab's
Ja.
Kopfhörer.
Yeah, great.
Super. And what I would do now is to check all the inputs individually. And the last one, it's this aux in, which is hardwired to the output, so you don't have an attenuator for it. It directly goes to the output then.
It's the same, like,
And yeah, if this also works, then everything.
so if you're not sure if one channel or so not working, maybe in the schematic you can see the left channel is always mono, so the signal will follow if nothing is connected to the right channel. The left channel signal will go also to the right channel as well. So
normalized to the other side.
yeah.
Okay, we have still a question from Mutant to the power connector. Where's the ground and where's the plus and minus? The ground is in the middle, and on the right side it's plus.
So there you can see, and on the connector we have this red stripe. You also have the white stripe on your PCB.
this is minus 12 volts.
Yeah.
Yeah,
Where the
this-
white stripe is, there's minus 12.
And then you have this whole middle area of 3 double pins, which is everything ground. Means also when you measure or when you use the multimeter with this beep function, all these will beep. This is all one thing basically. This is all ground. And here's minus 12 volts and here's plus 12 volts.
Okay. He doesn't have a spare rack, and he's a little bit worried to kill his 3,000 euro case. I hope this helps.
No one wants that, yeah.
Mm.
No one likes to put something in this rack he don't know.
Yeah, that's
Do you have a
basically good
multimeter?
idea anyway, to use a little spare rack like we have here too. You can't see it at the moment, but we have this little spare rack, a small ear rack case, and if something really fucks up hard, nothing of the other modules is affected. It's just, I don't know. I always take a small case and just put 1-2 modules into it. So if something really fucks up hard, then only these small modules are affected. So this is always a good idea, not to mess with your entire module system when you have done a new DIY module or something. To test it in a small case is always a good idea.
Okay.
Oh, yeah. Or you buy your small DIY power connection. There are, I think from Frequency Central, there are small power connectors for 1 or 2 models, and I think that's fine to test them out. And I think it's worth it if you done much DIY and you don't want to put it in your big rack and you have no idea if it works and you don't want to destroy them. I think that's a good way.
Mutant Labs, is this is the question answered now about the running you through the process?
The funny thing is, we have a slight delay of sometimes 25 seconds, so
Okay.
sometimes we have to be a little bit patient.
Okay, I will show it again, no problem. Then I will take here
Mach dich nochmal groß.
this one. So you can use up your multimeter with
Yeah, so it's
ohm or this with the beep. I will use this with the beep because it indicates on sound as well, and you don't have to look on your multimeter. So, and what you have to do is these 2 pins, this row of 2 pins on every section. Here on my left side, these are the minus 12 volt. They are together. If you put here and here your tips, then it sounds, because these are one section and these are minus 12. In the middle we have 3 rows. 1, 2, 3 with 2 pins, and these are the ground connections. So if I put my 2 tips in the middle between the 3 pins, then it also have a short connection. And also only the 2 pins on the right side, they are plus 12. So you have to check if you have any connection on this 2 with these in the middle, or with this on the right side. And you have to check this on the right side, the plus 12 power connector.
I think he had
in
it.
the middle. Then you're fine.
And we have some... okay, it works fine. Really cool.
Yeah, hopefully everyone is fine, is working. I can't see. Also falls du nach den Connectern suchst, das Problem ist auch gelöst, ne?
Ja, ich weiß.
And we will post a link for the differ site also here, so you can look.
Yeah, Andrea, thank you. You're welcome.
Ah, ja.
Great. We made it. You made it. So,
Yeah, I'm
Big,
sure
big
we do
thank
another
you.
one in January latest.
Mhm.
I just spoke to Befaco the other day, and we planned something together. So, yeah. Good.
Great.
So.
So, is anything left to say?
Yeah, Henrik, you're welcome.
Sehr schön.
So, if you have one last question, write it now. About the circuit. Well, I think so. I hope it works for everyone and you have fun with your Stereomix model. And thank you to be with you and to explain you how to solder it, and hope you will get into DIY a little bit more and have fun with it and starting soldering new modules. And if you're not sure, you can meet us up to the next virtual day, solder virtual day.
Yeah. Yeah.
I think there will be plenty more of this.
More.
Okay.
Great.
Then I would say thank you.
Have a nice evening.
Have a nice evening.
Bye-bye.
Tschüss.